Hello, this is Les. Welcome to my YouTube channel. Today I'm going to show and talk about the fourth multi-pump pneumatic air rifle that I built. And each time I build one, I make some changes and see what turns out, how it works. So this is the fourth one I built. If you're interested in seeing the first three, I have some other videos showing those. I'm going to go over this air rifle, show how it works, how I built it, and I'll disassemble it to show the simplicity in the parts. And then I did purchase a chronograph, so I'm able to test the velocity and the energy now, and I will do that towards the end of this video also. I want to say the gun is fairly easy to build, and I've learned things by building the first ones. For example, the first one that I built had a little bit longer air reservoir in there. I didn't realize how small the air reservoirs on these rifles are, so that they pump up fairly quickly, and they pump up to quite a high pressure, and that's the high pressure is where you get the energy and the velocity. So the first one I built had quite a large reservoir, quite a length of pipe in this part of the gun right here, which is the front part is the pump, and then the reservoir, and then this is the transfer port, and this little spot right here, and then the bolt is there. Anyway, the first gun, you have to pump it an awful lot, but it pumps very easy. A child could pump it all day long, and if you pump it long enough, you eventually build the pressure up where it shoots at a pretty good velocity. But this one here and the later ones that I built, I all made with a smaller reservoir, and so they pump up pretty quick. Like that. So what's different about this one is it has a little bit stronger of a hammer spring in there, or striker spring, whatever the terminology is for that, because some of them the air wasn't completely discharging. I'd shoot the gun and the valve would bounce back, and I guess that's quite typical for pneumatic air rifles. And then you'd shoot it and there'd still be a little bit air in the reservoir. So on the second shot, you wouldn't really have to pump it up as much, or you could push the trigger in and release the air and start all over again. Again, this particular rifle has a stainless steel tube. Inside here is a stainless steel tube. It's a 1/4 inch 3/16 stainless steel tubing. It's smooth wall. I had a comment from a fellow that said, well, can they really be called air rifles if they don't have rifle barrels? And that's probably correct. It probably would be called a musket with a smooth bore. This gun is very light. I weighed it on a bathroom scale. It weighs about 3.5 pounds, so it's very light. That's one of the, I think, nice features. It has, this one I added fiber optic sights. I don't know how well that would show on there. The rear sight has 2 green fiber optic, and the front sight has a red fiber optic. I don't know if the light is catching that or not. then a reader commented about how there's a tendency for the levers to fall open, that I should make some kind of a latch, and I did that. Basically, there's a little button right there that pops up, and that fits into kind of a little nylon washer right there. So pump the gun up and then snap it in, and it stays in place. I've watched a lot of videos on the Botan air rifles, and the Springers are very popular. They're very powerful, but I understand they're heavy and they recoil. So this gun is completely recoilless, and they talk a lot about the triggers, and I think this trigger would be considered pretty good, although I don't know, I've never owned an air rifle, and it would be interesting for somebody that had expertise in air rifles to comment on this. But since you're only releasing a very small spring, there is really not a lot of tension on the triggers. So it pulls with, oh, maybe a couple pounds of force or something. I haven't really measured it with a gauge, but I know it would be much more difficult where your trigger is releasing a heavy, strong spring versus just this light little striker spring. Let's see, what else do I want to say about it. The wood stock is made from a very cheap piece of cedar, which is a light soft wood. It does have some grain in it, and probably would not be strong enough for a rifle or a heavier gun, but since this one is so light, and I think this configuration with the open thumb stock makes it a little bit stronger too. I suppose the weak point would be someplace in here, but with the straight grain growing through there, I think it's probably pretty good. I'm going to take the gun apart and talk a little bit more about how I built it. For anybody that would be interested in building an air rifle, a multi-pump pneumatic, this would probably be helpful to see how the parts look, and I can talk a little bit how they were made. So I think that covers everything. I went over the safety, which is just a trigger block. I went over that in a prior video. So I'm going to move the camera setup. This little bolt is just threaded into, the bolt lever is just threaded into the bolt, and it actually is a little bit loose. And then the end of the bolt has a little O-ring washer on the end for sealing it. The front pump is held in by one small little bolt that holds the pin in. It's a little hex head stainless steel bolt. Could have used anything, I guess, but and then there are some spacers in here that are cut out of aluminum that go on each side. And here's the piston. I'm going to wipe it off so I don't get greasy. Just a common O-ring on the piston. And I was originally using a 3-in-1 oil. I was having a little bit of a problem with the valves and the valve that releases the pressure getting soft, and I think the oil was softening it, so I ordered some special Craftsman oil, and it has it says it's a doesn't say anything, but it seems to work better. And then I made this long tool right here for removing the valves. The Botan air guns have a little removable valve that sits right in here, but in my case I just have a plug that's soldered in the copper pump tube here, and on each end there's a valve core, and they're easily removable. Just go in with this long tool. That's the valve right there. So the plug that's in there looks something like that, and that's soldered in on this end, on the front end of the pressure reservoir. So that's what the hammer or the striker looks like. And when you cock it, the trigger has a little sear that fits up against this groove right here. And yeah, this whole piece then is just copper plumbing pipe that's soldered together with some couplings, and the magazine up here is a piece of brass that's drilled and soldered on with some little square blocks. And then to reinforce it, these are just copper couplings. The trigger mechanism down here is I just cut a piece of the copper tubing. I slit it and then expanded it so it would fit over the main body, and then silver soldered these pieces of copper onto it. And it's very soft, so if you get a little bit crooked, you can straighten everything up afterwards fairly easily. And there's just a little spring in here to pull everything back, and these little retaining clips. And that's what the trigger looks like. And the other part looks like that, and that's what the trigger goes in there and pulls that down to release the striker. So that's all there is to that. So right up in here is the transfer port, and the firing pin mechanism. There's another little hex head bolt right here that has to come out. So this is what the striker hits, and has a little O-ring on here for a seal, and then this is a groove to lock it in. That little hex head screw goes in there and holds that in place, and the striker hits this like that. And that hits the Schrader valve. So this end right here of my tool removes the large Schrader valve, which is the pressure release valve on this end. that's what it looks like. Now I opened it up to make the air passage bigger by using a little ball cutter on a Dremel tool. And on this end I can put it in my lathe in a collet and trim this front side of the washer back to make that a little bit bigger. But it's not very big, but seems to be big enough. So all my guns are based on using these replaceable valve cores. The small one is just a standard tire core, and then this one, I don't know if these were used in large truck tires, but I know they're also used in air conditioning units. Initial problem I had were the firing pin was going too far and smashing this little spring. So I had to get that to just the right length so it wouldn't damage that spring. So there's some slots that have to be cut in here. Obviously there's a slot on the bottom for the lever, the pump lever. But otherwise it's just a copper pipe which soft solders very nicely. And the key really is just getting everything nice and straight and then soldering it together. Otherwise it's very simple. I made a little pump gauge right here because I was curious what kind of pressure I was getting out of my pump, and I made that using a part of a valve core, and that just goes in there and screws in there like that. In fact, I'm going to put this together and I'll show you what kind of pressure I get for a different number of pump strokes. Whoops. Got to put the valve in first. Oh, incidentally, I saw the pin off so that otherwise it would be sticking up, and when the piston comes down, it would hit it. So I just saw those for the intake valve. I just saw those off. Well, there's 6 pumps, and it's reading about 675, or I mean 375. So I'll write that down. If I can get anything to work here. 6 equals 375 PSI. Okay, this time I'll go 8 pumps. And this time we've got 420, 40, 60, about 480. So 8 pumps, 480 PSI. I'll go 10 pumps this time. 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, 590 PSI, I'm going to call it. So 10 pumps is 590. And 12 pumps, and then that's as far as I'm going to go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 pumps is 700, almost right on the button. So 12 pumps is 700 PSI. Okay, I'm going to turn the camera off here and put the gun back together. I don't think there's anything else I wanted to show. Other than this is a detailed drawing of the valves. This doesn't show the copper pipe. I've got a note on the top here. The first rifle had a 1-inch long space between the plug where the intake valve is and the release valve, and then the second one and the third and the fourth were 3/4 of an inch, so it wasn't that much difference. But there was also some changes in the pump stroke length and the lever distance on the pump, so that changed some also to give me a little bit longer stroke, which of course again makes it a little bit harder to pump. As I mentioned, the first gun, I think a child could pump that all day long. It pumps so easy, but it probably only shoots 600 feet per second comfortably. If you want to pump it, you can get probably get it up to 650, but shoots very nice at 550 to 600 feet per second. For this one, we'll shoot up to 700, and if you pump it all the way up to the 700 psi. Okay, I'm going to put the gun back together. Well, I'm back set up with the chronograph, and you can see the target and the distance. Although the camera is set up at kind of a oblique angle, so it's going to look a little weird maybe. I'm shooting these Gamo Master Point pellets, 7.56 grain. And then here's the chart I'll be filling in. The number of pumps, the pressure, I'll be filling in the velocity, and then I'll look up the energy. One, 2, 3, 4, 5, 6. Okay, 6 pumps is 576 feet per second. One, 2, 3, 4, 5, 6, 7, 8. 636 is the reading. One, two, three, 4, 5, 6, 7, 8, 9, 10. 673 for 10 pumps. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 pumps is 711. So I'm going to pause it right here and go look up the energy for these velocities and this pellet. Well, here's the results. If I can get it to fit on the camera screen here. So at 6 pumps, the pressure was 375. The chronograph velocity at 6 pumps. Now there may be a little difference between when I'm using my pressure gauge because the pressure gauge does have a little bit of volume, which increases the volume and the reservoir volume, which would decrease the pressure. So the pressure may actually be a little bit higher than 375 at 6 pumps without the gauge in there. I don't know if that makes sense or not. But. And then the energy at that velocity is 549. And then at 8 pumps, the pressure was 480. The velocity went up to 636, and the energy went up to 6.69 foot-pounds. You probably noticed that the velocity, the energy increases with the square of the velocity. So if you double the velocity, you would quadruple the energy. On the other hand, the pressure is more directly related to the energy. So that if you double the pressure, you double the energy. More or less. There's a lot of variables involved. At 10 pumps, the pressure went up to 590 psi, the velocity went up to 673, and the energy went up to 7.49 foot-pounds. And then at 12 pumps, the pressure went up to 700. The velocity went up to 711 feet per second, and the energy went up to 8.36. So I don't know if that's good or not. It's just, like I say, it's just a small rifle, so for plinking, it's probably okay. I'm sure the Botan rifles, although you have more pumping effort, they can probably pump to higher pressures and then consequently higher velocities and more energy. But at 700 psi, I think I'm reaching the limits of my materials. Like I say, I'm just using Schrader valve cores, copper pipe, common off-the-shelf O-rings, and I think that 700 pounds is probably reaching the limit of some of those materials. Here's the target at 10 yards. Not very good. I'm not a very good shot. I don't see the front and rear sight in focus at the same time. I put on a pair of very weak reading glasses so that I can see the rear sight a little bit sharper, and also for some eye protection. But and then I did look at the chart, and there's about a 1/4 of an inch difference in the drop between the 700 feet per second and the 6 pumps, the 576 feet per second. I think 2 of the bullets went through this hole right here, and then that one and that one. I really haven't found any difference between the guns that I made that have rifled barrels. As I mentioned, my first rifle has a Crosman barrel, and the second one has a Daisy Powerline barrel, and they're both supposedly rifled, whereas the last two just have the stainless steel tubes. And the way I built this one right here is I can screw that tube right out of there with this Allen wrench that goes in there, and then you can, I guess I won't take it out, but I felt that if there was a major difference in the accuracy of the stainless steel tubing versus the barrels, that I would just get a barrel and I would screw the tubing out and screw a rifle barrel in. But at this point I really don't see a need to do that. So anyway, I'm sorry that this video got to be so long, but thanks for watching, and send me a note if you have any questions. Thanks for watching.